Water is the lifeblood for southern Alberta. The Alberta agricultural industry and the economy depends on the St. Mary irrigation system to sustain our crops, which in turn feeds people around the world. The St. Mary Dam and Reservoir are located roughly 60 kilometers southwest of Lethbridge, Alberta. Since construction of the dam in the 1950s, water has been impounded in the large reservoir for irrigation use. Here, a spillway serves to pass high flows and floodwater safely from upstream to downstream. But there is also a 2,200-foot long, 20-foot diameter concrete tunnel underneath the dam. This outlet's primary purpose is to maintain a constant flow of water in the St. Mary River downstream of the dam. Approximately 700 feet downstream of the trash racks, a concrete plug separates the submerged upstream end of the low-level outlet tunnel from the downstream. The concrete plug is 20 feet long and prevents the reservoir draining through the tunnel. Two conduits pass through the concrete plug. Immediately downstream of the concrete plug, there is a guard valve on each of these conduits. These valves are used to stop the flow through the conduits. These valves were installed during the construction of the dam around 1950 and were designed to last 50 years. Approaching 70 years of service, the valves had deteriorated and were leaking heavily. Downstream of the 72-inch guard valve connects to a hollow jet valve, which dissipates energy and controls the water flow rate through the tunnel. This hollow jet valve was also installed in the 1950s and also leaked heavily. And as these valves would continue to deteriorate, the valves would eventually fail. Failure of the valves could have severe repercussions for the agricultural region and the downstream users that rely on the water from the St. Mary Dam. As draining the reservoir was not an option, plugging of the tunnel or conduits would have to be done underwater. Replacement of the valves was a unique challenge and required a unique solution. Alberta Transportation contracted Clone Krippenberger to develop the solution. Hibbard Inshore is a technical services company specializing in the use of remotely operated vehicles, or ROVs. The Government of Alberta has brought them onto this project to design and install two isolation barriers, essentially plugs, that will block the 72 and 12-inch conduits and allow the valves downstream to be replaced. Deployed from a barge on the reservoir, Hibbard Inshore used two customized ROVs. ROVs were used instead of divers for safety reasons because of the depth and travel distance inside the tunnel to where the isolation barriers need to be installed. Deep below the water are a set of trash racks at the upstream end of the tunnel. The first ROV, the large Mohican, attached a lifting device which was attached to a 20-ton hoist on the barge. To make enough room to pass the isolation barrier through the trash racks, a top portion of one lower trash rack panel had to be removed. The ROV returned to the barge to have a saw attached. With this, Hibbard Inshore's ROV made a series of cuts. At this point in the project, the large 72-inch guard valve was closed, reducing the flow through the low-level outlet to the minimum leakage rate past the valves. The Mohican entered the tunnel and traveled up to the upstream face of the concrete plug. Here, the Mohican used a different saw to trim the rebar protruding from the face of the concrete plug. Prior to the isolation barrier installation, Hibbard Inshore deployed the Mohican ROV to dredge out sediment. The dredging was necessary to clear out enough space to install the isolation barriers. The ROVs moved the isolation barrier through the trash racks and down the tunnel toward the conduit intake. The Mojave disconnected, and the Mohican pushed the isolation barrier into the conduit bell mouth intake. Once the isolation barrier was properly positioned, the mechanical and inflatable seals were activated. This process is repeated for the 12-inch barrier using the Mojave alone. Both guard valves and the hollow jet valve were then opened, allowing water to drain from the conduits. The team from Simpson Industrial Services began their demolition work in the downstream side of the low-level outlet tunnel. The original hollow jet valve was removed first to give the workers better access to the guard valve and hydro rooms. The actuator for the 72-inch guard valve was removed and transported down the tunnel. The flange coupling adapter was loosened and the 72-inch penstock was slid downstream. A 2-foot-long section of penstock spool is removed. The guard valve is disassembled and removed in 3 pieces. The 72-inch penstock was then slid back upstream, and the flange coupling adapter was removed. In the hydro room, the TransAlta discharge piping above this section of penstock restricts how the penstock can be removed. The penstock is cut so it can be pulled downstream and out of the tunnel, along with a concentric reducer. At this point in the project, the demolition phase was completed and the installation phase started. First, a new flange coupling adapter is installed. This one is 2 feet longer to account for the removed 2-foot-long spool. The penstock is slid into the flange coupling adapter so that there is space for the new guard valve to be installed. Because this new valve is a single piece and space is limited, a complex series of maneuvers is required to bring the valve into the tunnel. With the valve in place, the valve actuator and counterweight are installed. Back in the hydro room, a new penstock reducer was added. The new reducer is eccentric rather than concentric, and shifted the center line of the penstock to allow space for the much larger VAG-supplied hollow cone valve. A new section of 56-inch penstock was installed and connected to the reducer with a robar coupling. Concrete was poured to construct a new thrust block, capable of holding the valve against the immense force of the water that will flow through the low-level outlet tunnel. The new hollow cone valve was finally ready to be installed, completing this section. Back up in the guard valve room, sections of the 12-inch and 6-inch piping were replaced, and final touches were added. Hibbard Inshore returned to site. The ROVs returned to the tunnel and opened valves that allow water to pass through each of the isolation barriers, flooding the space between the isolation barriers and the new valves. With the pressure across the isolation barriers balanced, the isolation barriers were removed. The new 72-inch guard valve, downstream penstock and piping, and hollow cone valve were wet tested and put into service. With this work complete, the St. Mary Reservoir will continue to safely serve southern Alberta for another generation.